Okay guys, let's get into the next one. This is another topic that is specifically and explicitly outlined in the advanced information. It's the error intervals first, for the first one there, error intervals, and then it gives a little hint. There's something about a calculator. So I'm going to go through an error intervals question, which will require a calculator. So let's look at the first one. It says a number x is rounded to two significant figures, and that number is the result is 210. It says write down the error interval for x. So we take 210. So if it's two significant figures, that's the first significant figure, and that is the second significant figure. So we're looking at this value here. So we're looking at tens, so we'll take a 10. We'll divide it by 2. We get 5. So to work out the upper bound, we do 210 plus 5, and for the lower bound, we do 210 minus 5. Okay, so all we do now, put our x in the middle there. Remember, x has to be lower than 215. If it's 215, it will round up. But if it's 214, it will round to 210. And then the lower bound is 205. But with the lower bound, it can be 205. That's why it's got this less than or equal sign. So that's how we lay out our boundaries. Let's do the next one here. So we've got 0.458. Okay, so 0.458 to three significant figures. So that's our first significant figure. That's our second significant figure. That's our third significant figure. So we take 0.001, we divide it by 2, we get 0.0005. Okay, so we want to work out the lower bound and upper bound. To work out the upper bound, you do 0.458 plus 0.0005, and for the lower bound, you do 0.458 minus 0.0005. Okay, and then we just place it in the same parameters. So x is less than, it has to be less than 0.4585, and 0.4575 has to be the lower bound. Anything smaller than and itself included, because if it was 0.4575, it can be rounded up to 0.458. Okay, so this is the easy stuff. And to be honest, the next bit is easy as well. Some easy marks. And if you don't remember this, then it's your own loss, because I have a very, very, very strong feeling this is going to come up. When we look at how accurate the advanced information was for paper 1, the paper 2 can only be so accurate too. They wouldn't be just out of nowhere, not following it anymore. So let's get on to a slightly harder question. So let's look at this question here. A box is a cuboid with dimensions 27 centimeters by 15 centimeters by 20 centimeters. These dimensions are to the nearest centimeter. Okay, so these are to the nearest centimeter. DVD cases are cuboids with dimensions 1.5 to by 14.3 by 19.2. These dimensions are to the nearest millimeter. So they've kind of been being a bit sneaky there. And remember, that's what's going to probably happen in the exam. There's going to be a little bit of sneakiness, but it is what it is. You're going to be prepared for it. You got to have that winner's mentality and just crush it. So let's work out the upper and lower bound for the 27 first. Now remember, this is all about widths. This is about how many of these can fit in this width. Okay, all the other lengths are useless to us at this point. So we take 27. The upper bound will be 20. Remember, it's to the nearest centimeter. So we're taking 1 centimeter, and we're dividing it by 2. We'll get 0.5. Okay, so the upper bound will be 27.5. The lower bound will be 26.5. Okay, so that's for the 27. Let's take the 1.5, which is to the nearest millimeter. Okay, so this is to the nearest millimeter, so that's a centimeter there. Okay, and so we're taking the millimeter, so it'll be 0.1 divided by 2, we get 0.05. So we add it on. The upper bound would be, let's choose a different color now. The lower bound would be 1.45 because we take it away, and the upper bound will be 1.55. Okay, the logic here is that will the largest possible size of CD fit in the smallest possible width available? Okay, so you're trying to find out, will the biggest possible CD fit in the smallest possible width? Okay, because they're asking us, will it definitely fit? So if we're doing it in any other combination, it wouldn't make any sense. So we want to work out, will the biggest possible CD fit in the smallest possible width? So the smallest possible width would be, remember, 26.5. So if we get a value less than that, amazing. So let's take the largest possible width, which is, let's use another color for this, 1.55. That's the biggest, that's the essentially the fattest they can ever be. They can't be any bigger than that. So you're taking 1.55 and you're going to multiply that by, how many have we got? 17. So we've got 17 discs. So if we stick that into our calculator, we will have a combined width of all of the fattest discs stacked together, and that will give us 26.35. Now the question is this smaller than the smallest possible width for this length here? That was the smallest possible width. 26.35 is less than 26.5. So therefore, it will absolutely fit.